Hey there class, Mr. Prosky here. Hope you're having a good day so far. We're continuing with 1.6 in geometry, which is classifying polygons. Our essential question is how do we classify polygons and how do we solve for missing angles and side lengths of regular polygons? All right, so a polygon, this is the formal definition, is a closed plane figure with the following properties. It is formed by three or more line segments called sides, and each side intersects exactly two sides. Yeah, you get the idea. Basically, a polyside is the definition we're going to use down here is right here. Triangle, quadrilateral, pentagon, etc. It's going to have no curves. It's a two-dimensional shape that has no curves, no sections. We're going to put comma and is connected. Okay. So that's the basic definition. It's basically a three-sided or more, three or more sided two-dimensional shape that has no curved sections and is connected. Okay, so the side. Let's draw a shape here. I'm going to try to draw a polygon. There's how many sides is that there? That is 5 sides, which makes it a pentagon. Okay, so the sides are going to be just basically the line segments here. Those are the sides. Okay, these are the sides. All right, a vertex. It's the end point. You could also call it a corner. Okay, a what? A corner of a polygon. All right, so the corners would be like this right here. Okay, so the sides are basically going to be the line segments, and the corners are going to be vertex. And actually, the plural of vertex is vertices. Say vertices. Let me rewrite that. That's really bad. Vertices is the plural for vertex. All right, convex. A convex convex polygon has no dents. No what? No dents. So for example, if we draw like a diamond shape here, there's no dents in here. There's nothing, it doesn't go inward at all, right? A concave polygon, this actually refers to some science terms. Concave has dents. It has dents. So for example, if I draw this shape like this one, you can see that it has a dent right here. Okay, it goes inward. Okay, and these shapes are not perfect because I can't really draw straight lines on here, but let me just try something. Can I do that? No, it won't let me. All right, so, and it says a cave is a big dent in the earth. That's kind of how you remember that. So cave is going to be dense, convex has no dents, it goes outwards. All right, an n-gon is a polygon with n sides. How many sides? N sides. So for example, and on page 43 of the book, if you wanted to use the book, is there. If there's 37 sides, we don't really have a name for a 37-sided figure, so we would literally just call it a 37-gon. Okay, a 37-gon has 37 sides. Okay, equilateral, equiangular. Equilateral means all sides are congruent. What are congruent? All sides. And equiangular means all angles are congruent. What are congruent? All angles. All right, we're almost done with all the vocab here. We'll move on to some of the more engaging stuff here, okay? A regular polygon. A polygon is regular if all sides, all what? And all angles, all what? Are congruent, both equilateral and equiangular. Okay, let's get into some actual examples here. All right, so a polygon can be named by listing the vertices or corners in consecutive order. So we could start at A and go around this way. We could start at C and go around this way, okay? As long as you're consistent and go around the polygon all the way back to where it started, that is totally fine. So for example, A, B, C, D, E would be a way to name this polygon, okay? Why don't you guys come up with another example here? See if you can come up with another example that's using any starting point and going all the way around the polygon. All right, the other one that I chose was C, D, E, A, B. Okay, that's how I can name that polygon. If you came up with some other examples, as long as you started at a corner and went around all the way back to that corner, you should be totally fine. Okay, let's talk about identifying polygons. So remember, a polygon is no curves, no sections, and is connected. No curves, no sections, and is connected. Let me write that up here. No curves, no sections, and it's connected. Okay? All right, so let's go through an example here, then you guys are going to try a few, all right? So let's look at example A. Are there any curves in here? Any curved sides? Like if we had like something like this, this would be a curved side, right? Are there any curves in A? No. Are there any sections in A? There is. There's a section here and a section here. So this one is going to be no. And the reason why is it has two sections. This is not a polygon because it has two sections. It needs to be one continuous thing here, okay? All right, you can pause the video and try the rest of these, see if you want to do, or else you can keep following along with me in a second here. If we can pause the video or keep going. All right, B, are there any curves? No. Are there any sections? No. Is it connected all the way around? Yes, it is. This is a yes, is a polygon. Now, is it convex or concave? Are there any dents in here or no? There are no dents. This is going to be a convex polygon. All right, how about C? Any curves? No. Any sections? No. Is it all connected? Yes. This one is yes, it is a polygon. And does it have any dents or no dents? It has this dent right here, so this is going to be a concave polygon. All right, and then checkpoints 1 and 2 are the same thing. For checkpoint 1, are there any curves? No. Are there any sections? No. And by sections, what I mean, go back to A here. See how this line kind of separates the two parts of the polygon? That's what I mean by sections, okay? So no sections. Is it connected? This is yes. And are there any dents or anything, or no? There are no dents. This is going to be convex. Convex has, convex has no dents. How about number 2? Checkpoint 2, are there any curves? Well, there is a curve here, so this is going to be no. And the reason why it's not a polygon is it has, has a curve. Polygons have no curve. No curves. Okay, let's talk about congruent shapes here. Okay, I'm going to draw a triangle and then a quadrilateral, or like kind of a trapezoid kind of thing. So I'm going to draw a triangle here and a triangle here. It's meant to be kind of similar. And then I'm going to draw kind of a trapezoid kind of thing. Not perfect. That was really bad, actually. Let me fix that. Not perfect, but so the way you can show that angles are congruent are a couple different ways here, okay? You can use arcs, like this angle, if there's another angle over here, it'd be congruent to that angle, okay? Or you could do 2 arcs would be matching with this angle, and then 3 arcs would match with this angle. But another thing you might see in some textbooks or some text is that instead of doing arcs, I'm going to draw another triangle here in the middle, okay? Instead of drawing just like arcs, draw it better, you'll actually see like an arc with a tick mark through it. So this would be a 2 arc here, this would be a 3 arc. Okay, that's another way to do it. So you could have the matching tick marks with 1 arch, or you can have matching arches here, okay? So we draw another trapezoid here. Okay, so like I said, you could use these two match with 2 arcs, or you could go arc with a tick, arc with a tick, arc with 2 ticks, arc with 2 ticks. Okay, that's how you show which angles and sides are congruent. Angles are congruent. Okay, let us classify some polygons now. What does classify mean? Basically, we're going to name it, okay? All right, so we're determining what kind of polygon it is by the number of sides, and then we're determining whether it's equilateral, equiangular, or regular. Okay, how many sides do we have? Well, let's count. We got 1, 2, 3, 4, 5, 6, 7, 8. What's an 8-sided polygon called? It is an octagon, okay? And refer to the, there's going to be a formula sheet that will, there's a formula sheet that will, have all the different types of polygons, okay? Now, is it equilateral? Well, all these tick marks here mean that these sides are congruent, so it is equilateral. Is it equiangular? Well, all these little arches here mean that all these angles are congruent. So if it's equilateral and equiangular, well, by definition, that means that it's a regular octagon, okay? Alrighty. Okay, moving on. Example 4. The head of a bolt is shaped like a regular hexagon. The expression shown represents side lengths of a hexagonal bolt. Find the length of the side. Okay, so a couple things. Regular, what that means is that all the sides and angles are congruent. So what we're going to do is we're going to set equal and solve. We're going to set, equal, and solve, okay? All right, so this is a regular hexagon, means all the sides are congruent. So what are we going to do with, oh, a hexagon, I forgot to mention, this is 6 sides, right? We're looking for the length of a side, like the box what I'm looking for. Okay, so we're looking for the length of a side. We know that the measure over here is 5x minus 1, and this one is 4x plus 3. What are we going to do with those two lengths there? Well, if it's regular, it means they're congruent, so we can set them equal. So 5x minus 1 equals 4x plus 3. Okay, if you guys want to pause the video and try to solve it from here, why don't you go ahead and do that. All right, next thing you're going to do is subtract 4x from both sides. We're doing some solving here. We get x minus 1 equals 3. Add 1 to both sides. X equals 4. Are we done? Well, no, the side is going to equal. We can either plug into 4x plus 3 or 5x minus 1. I'm going to plug into 4x plus 3. Okay, so we got 4 times 4 plus 3. 16 plus 3. So the side is equal to, 16 plus 3 is 19 millimeters. And that's how we do it. All right, why don't you guys go ahead and try checkpoints 3 and 4. Give them a try, see how you do. Okay, classify the polygon by the number of sides. Well, I see 1, 2, 3, 4. A 4-sided polygon is a quadrilateral. And now, is this equilateral? Are all the sides congruent? Well, these two are, but it doesn't say anything about these two, so it's not equilateral. Is it equiangular? Are all the angles congruent? Well, no, this angle is congruent to this angle, and this angle is congruent to that angle, but they're not all congruent. So this is going to be, and it has to be both for it to be regular, so this is going to be none, okay? So why don't we write that down here. Not all angles are the exact same, and only one pair of sides are congruent. Okay, you can pause the video and copy it down if you would like to. That's the reason why. Okay, checkpoint 4. The expressions 4x plus 8 and 5x minus 5 represent the measures of two angles, two congruent angles in a regular hexagon. Find the measure of an angle. All right, well, if it's regular, and regular means, I'll write that down over here. Regular means equilateral and equiangular, which means angles and sides are congruent. So we're going to set, equal, and solve, okay? That's what we do when it's regular or equiangular, equilateral, okay? So we're going to set 5x minus 5 equal to 4x plus 8. All right, let's solve this from here. We're going to subtract 4x from both sides. We get x minus 5 equals 8. We add 5 to both sides. We get x equals 13. All right, now which one do you want to plug into? 4x plus 8 or 5x minus 5? I'm going to plug in, measure the angle. I'm going to plug into 4x plus 8. Actually, let's do 5x minus 5 this time. Why not? 5x minus 5. You can plug into either one, though, because they're congruent. So 5 times 13 minus 5. So 5 times 13 is 65. So we got 65 minus 5. So the measure of the angle equals 65 minus 5 is 60 degrees. All right. So you can plug into either one, though. Just keep that in mind. All right, that's all I have for you today. Thank you for watching. Have a great day, and we will talk soon.